Hello and welcome to QBA Clips. The purpose of the video clips that we'll be watching in this series is to augment and supplement the material that's covered in your textbook. So in some cases we may provide additional examples, in some cases provide perhaps some additional clarity on some of the concepts. But these will be a series of brief video clips, and the first of which will be from our first block of material. And the learning objectives for this block of material include understanding types of data, creating and interpreting histograms, understanding relationships among data between pairs of variables through the use of scatter plots, and understanding time series plots. In this first brief clip, we'll talk about understanding types of data. Now, there are several ways that you can categorize data. One way would be to consider data as being either numerical versus categorical. Numerical data is also called quantitative data. Categorical data very often is called qualitative data. So this is one way that you can categorize data into types. Another approach that's often used is to think about data as being cross-sectional versus time series data. Now, cross-sectional versus time series is a totally different way of considering data types compared to numerical versus categorical. So numerical data could be either cross-sectional or time series, and categorical data could be either cross-sectional or time series. So they're two different ways of parsing out different types of data. And we'll briefly look at each of these. Numerical data involves looking at quantitative values. The observed and recorded values for the variable are quantitative values. And therefore, we'll be considering, certainly in quantitative business analysis, real numbers. And those of you who have engineering backgrounds may be aware that there are non-real numbers called imaginary numbers, and they have their very valid purpose in the world, but we won't do too much in business with imaginary numbers. So our focus will be on real numbers. And by that, we're talking about pretty much everything on the number line between positive infinity and minus infinity, including zero. So whole numbers, fractions, which can be expressed as decimals, etc. Positive numbers, negative numbers, zero. And the idea is that on real numbers, on numerical data, arithmetic calculations are valid. So this is one good way to check to see if our data is numerical. Does it make sense for me to do arithmetic calculations on this data and get meaningful information? And some examples of numerical data that we may run into in the business world are annual income, product weights, sales revenue, or production rate, number of widgets made per some time period on a manufacturing plant, for example. Now, numerical data can come in more than one flavor. It can be either continuous or discrete. Continuous data implies that there's an infinite number of possible values that the variable can take on. And by this, we don't mean that the value can go up to positive infinity or negative infinity. What we mean is that there are no gaps in the possible values. Generally, these are things that we are measuring with time or distance, for example, and we're limited only by the precision of our measurement instrument, the stopwatch or the yardstick that we're choosing to measure, or the scale that we're using to measure mass, for example. These would be examples of continuous data, and there's no gaps in the possible values. And we can contrast this with a discrete variable, and that's one in which there are gaps in the possible values. And very often when we think of discrete data, we're thinking of things that we're counting that come in whole numbers. For example, I gave 4 examples on a previous slide: annual income, product weight, sales revenue, and production rate. The obvious one of these that would be discrete would be production rate, the number of widgets produced per unit hour. Assuming we're only making whole number of widgets coming out of the assembly line, then we either have produced 25 in an hour or 450 in an hour or something like that, depending on what it is that we're making. Something like product weight or sales revenue or income very often are thought of as continuous variables. Weights, of course, would be a continuous measure, time or physical lengths of measurements will certainly be continuous. Income is one that very often is taken as continuous. Income and revenue, things attached with dollar values, we very often are really, even though we may have a currency attached to it that has a defined minimum denomination like pennies in the U.S. currency, but what we really are capturing is a measure of value. So very often we will actually, by convention, think of anything that we're measuring in currency or dollar amounts as being a continuous variable, even though we may choose in our economy to break it down to some kind of discrete number of pennies. So some of it is context-based, and some of it is by convention, but a lot of it is really based on just the practical uses of the variables themselves. Categorical data is the quality of an observation. And by this we're saying we're describing something about the item that is being observed. And very often we have to come up with categories that will allow us to capture each of the possible qualities that we may measure. And those categories, or sometimes they're called bins, have to have a few qualities of themselves, a few criteria. They need to be mutually exclusive and collectively exhaustive. By this I mean, if I'm coming up with a series of categories for a variable, I'll give you an example in a moment, but those categories have to exclude each other, meaning it has to be absolutely clear that a particular item that's observed must be either in one category or another. It can't be straddling the fence between both. So the categories have to exclude each other. They have to be mutually exclusive. And by collectively exhaustive, we mean that when we look at all the categories together, they have to span the entire spectrum so that nothing, no particular item that we're observing is being left out. We have to have a bin in which to place it, but only one bin in which it can go. So some examples of categorical data might be eye color, blue, brown, etc. And we can decide how carefully we want to parse that out. How different is blue-green from greenish-blue? We have to define those clearly enough that each person we were to look at for their eye color, we need to know exactly which bin they go into. So it's important for us to be clear when we're defining those kind of categories. If we were in the retail apparel business, we might have size of customers. So shoe sizes or clothes sizes may come in small, medium, or large. These would be examples of categorical data. Now, categorical data itself is often considered to come in more than one variety as well. And there's a little bit of a nuance from what's in your textbook. Your textbook implies that there really is one flavor, but there's one distinction that sometimes people make between what's called nominal data and ordinal data, again in the cases of categorical data. And nominal categorical data is just where we're using some kind of a descriptive name as the categories in the variable. So it's really just a name that we're given that's describing the quality. And sometimes we can use a placeholder instead of an actual descriptive name. So we could use a number. For example, Progress Energy might have various categories of customers, residential, commercial, industrial, and they might in their database decide, well, residential customers, we're going to call them category 1. Commercial customers, will call them category 2. So we can place a number in there as a placeholder for the name, but it still is nominal and categorical data. Just because we're using a number doesn't change it to numerical data. Ordinal data is very similar. It's a descriptive name, but something in the descriptive name of the category identifies a rank order of the values. So in the examples again on the previous slide, eye color would most likely be just nominal. We're just describing the color of the eyes, blue, brown, gray, hazel. Whereas size of customer, while we are also describing here small, medium, large, there is an implied hierarchy. Small we think of as being smaller than medium we think of as being smaller than large. So this is one of the areas in which we may find that people separate out categorical data into those that are ordinal versus those that are purely nominal. Okay, let's then leave numerical and the categorical data and look briefly at cross-sectional versus time series data. Cross-sectional data is where we were looking at observations of several variables, or just one variable perhaps, but at one given point in time. It's sort of a snapshot view. And we may, actually I'll post to Blackboard a data file called coding.xls, just as an example of some data that might be taken on a survey. That's cross-sectional data, so we can take a look at that. Another example that I'll talk about here is the For example, you might be interested in how SUV sales are going. So we may look at the first half of 2010 and look at sales across each of the major brands of sports utility vehicles. That would be cross-sectional data. We're capturing the data in one time period. Whereas we could also look at what's called time series data, in which we're measuring one or more variables at successive points in time with a view towards trying to see how those values are changing over time. So a similar example from the automotive industry is that rather than just looking at one time period, say the first half or the first quarter of 2010, we might track one or more brands of sports utility vehicle and see how their quarterly sales have varied over time, say maybe over the last 5 years worth of quarterly sales data. And then we might look for some things. We might look for trends. We might look for what we might call seasonality. We'll talk more about that later. But the key here is that the time series data is looking at the measurements, the observations, repeatedly, usually at precise and repeated intervals of time, to look for how those variables are changing over time versus the cross-sectional data where we look within one time period at one or more variable just to capture those values. Okay, well, that's our brief discussion on understanding types of data, and we will pick up in another short video clip with some of our subsequent learning objectives.